Hello, this is Mr. Wynn. This video will be about graphing rational functions. So a rational function is very similar to a reciprocal function, except now they're polynomials on top and bottom of the fraction. Again, where the bottom cannot be equal to 0. Let's see, there's zeros or roots where the top equals 0, but we'll do that later. What we do care about is there's still asymptotes. Vertical asymptotes still come from when the bottom equals 0. And then there can be at most one horizontal asymptote. It takes into account the degree of the top and bottom. If the degree of the top's higher, we have no horizontal, but we have a slant asymptote or oblique asymptote. It's diagonal basically. If the degree is less than, you have the asymptote y equals 0. If it's the same, then you're going to have an asymptote that's y not equal to 0, just some other number. Now there's some examples, but the good news is in our Algebra 2 class, we're not going to do those. We have simple ones. So our problems will always factor and then reduce to end up like a reciprocal. So everything's the same as before, except with one new thing. Restrictions that cancel out are no longer asymptotes, but holes in the graph, and I'll show you what that means in a bit. But here are the 4 steps now. First is factor everything, so we're going back to factoring. Second is find the restrictions that are vertical asymptotes and holes. Third, we find the horizontal restrictions. Remember, that's k. And then 4 is draw the asymptotes and sketch the curves. So first sketch this. Well, let's factor first. The top is unfactorable, stays the same. But the bottom is a difference of squares. So it's going to turn to x plus 3, x minus 3. So I factor everything. Step 2 was find the vertical restrictions. Well, if I said the denominator equal to 0, that means, so it's called vertical asymptotes, VA. X cannot be -3, because I make the bottom left parentheses 0, so 0 times anything 0, can't divide by 0. And it can't be +3. Now we need holes. Now holes come from vertical asymptotes canceling out. For example, you see how this top x plus 3 cancels the bottom x plus 3? Well, my bottom doesn't have the x plus 3 anymore, so this restriction no longer was a vertical asymptote, it's now a hole. So I'll put it down here. Cannot be -3. So let me erase this. So again, vertical asymptotes that cancel out become holes. They're not going to have a line that we can't cross. We'll see what happens in a bit. So let me fix this now. So now we have 1 over x minus 3. So I have one vertical asymptote and one hole. Next, do the horizontal asymptote. This is k. Well, k is 0. So my horizontal asymptote, I'll call the HA, is y equals 0. With that, I can draw my graph. So let's draw my asymptote. X cannot be +3. So let's call this +3. All right, what else? Y cannot be 0, so it can't cross the x-axis. Those are my only 2 asymptotes. Now I'll draw my curves. Since A is positive, A is 1, so y'all know how to graph this. That's what 8-3 was. I'll draw my curve. Straights up there and goes outwards until it flattens out. And down here, it's the reverse. Goes this way and goes that. I'm explaining what a hole is. So a hole, if that's positive, let's call this area right here -3. All right. They're telling me that there can't be a value there. So basically, it doesn't exist because the bottom be 0. So we put an empty circle, a hollow circle there. So let me erase that part. So here's what it should be. There should be an open circle at -3 and it keeps going like that. Domain and range, same as before. This will be all reals but our restrictions. Well, x cannot be, is everything but -3 because there's a hole there, and +3. So there's 2 things that x cannot be. Range, we use -infinity, +infinity, but the x-axis or y is 0. Y cannot be 0. Let me show you what this calculator graphs this like. So if I go alpha y equals x plus 3 on top, x squared minus 9 on bottom, you'll see that it's graphing like that. If I try to trace, let's see, trace -3, it'll give me a blank for y. So let me zoom in. Maybe I can see a little better. Let me graph this, and I'll zoom in a second. Zoom in is 2. Slightly off on picture. I'll show you a different picture, but you'll see a hole there, even in the calculator. Example 2, same idea. First we got a factor, so I'll leave this f of x. The top does not factor, it's already factored for us. I do not distribute. The bottom, you can do the ACX method. So 42 is 6 and 7, and 6 plus 7 is 13. So it's x plus 6, x plus 7, minus 3. So vertical asymptotes and holes. Well, the vertical asymptote comes from the bottom equal to 0. So x cannot be negative 6. I'm just changing the sign for the factor. Can't be negative 7. Now, again, we're going to cancel out now. Well, this x plus 6 cancels this x plus 6. So although we had a vertical asymptote before at negative 6, that's actually a hole. So we're going to move that down here. So let's erase, or let's cross this out, or I'll scribble this out. It moved. So only one vertical asymptote and one hole. Now the horizontal asymptote, the HA, that comes from K. Well, K is negative 3. Alright, so that's where my vertical asymptote is. Horizontal asymptote, Y cannot be negative 3. Alright, let's graph it. Draw your asymptotes. So let's do vertical asymptote at negative 7 for x. So let's call this negative 7. Call that negative 7. Let's see, y, negative 3. I really like negatives. Surprise. Negative 3 is right there. Now, what is a? A is 2. That's the top thing of that fraction. So let me rewrite this. So this finally turned into, reduced form would be f of x equals 2 over x plus 7 minus 3, which y'all now graph from 8-3. Let's draw the curves in. A is positive, so it goes on this side. Flattens out over here. It starts going upwards over here. Down here, flattens out. Flattens out. There's my graph. Extend this if you want. And there's a hole, so wherever x is negative 6, put an open circle there. So I'll say negative 6 is right here, so I'll put an open circle right there. All right. Put a circle right there. And that's it. Domain and range, everything but the restrictions. Domain is all reals, but x cannot be those two things. Can't be a hole or a vertical asymptote. Negative 6 or negative 7. Range, all reals, but y cannot be negative 3. Alright, here's a fun one. I already factored for you, so we can skip the first step. Just do all the restrictions. So vertical asymptotes, well, the first one is x can't be 0. X can't be, if you solve 2x plus 3 equals 0, that's negative 3 over 2. Positive 2, positive 7 over 4. But we see a lot of them cancel out. This x cancel that x. This 2x plus 3 cancel that 2x plus 3. This x minus 4x minus 7 cancel this 4x minus 7. So a lot of these actually change the holes. So let's go to the holes. So the holes were, can't have 0, can't have negative 3 over 2, can't have positive 7 over 4. Let me cross these out. So this is now gone, this is gone, and this is gone. So there's only one vertical asymptote in 3 holes. Try the other one. Let's see. So right now, here's our final equation. We're at 5 over x minus 2 plus 1. So that's the old reciprocal one. K touches the horizontal asymptote, so I'll call it the HA. Well, K is positive 1, meaning y cannot be positive 1. Let's draw our graph, and we'll check this in calculator in a bit. I won't check it. It's true. All right, vertical asymptote at x equals 2. So let's call this 2. All right, that's 2. K is 1. Finally, I'm starting up here. Let's call call that 1. Don't cross that line. A is positive, so draw the sketch in the top right. Then alternate to bottom left. Alright, now we have holes, so let's start putting open circles at 0. Well, alright, here's open circle. I'll just put open circle there. Don't erasing. -3/2, that's -1.5, so let's see, let's call this -1.5-ish right there. And 7/4, that's over here, because it's right before 2. So 3 holes, 2 asymptotes. Here's your problem, try that. You'll see there's a hole there. Now let me graph this one for you. I think this one has a nice hole you could see. So if I do fraction, x plus 5 over x squared plus 4x minus 5. On the side's plus 1, standard. Oh, we just can't see that well. Well, on your regular calculators in class, they'll have a nice little open spot where that hole is. Alright, that's the video. Hopefully you understood that. If you have any questions, ask in class. Again, this is Mr. Wynn. Thanks for watching. See you later. Bye.